Hi guys. Somehow this screen does not show anything. I don't know why. This is Edge. In case of Chrome, there is no such problem, but Edge does not show any screen here. But I try to record this like this, and then I try to see this in the YouTube channel, and then I can see the screen. So maybe this is the problem of Edge, but recording seems to be okay. So today what I'm gonna do is that yesterday I tried to solve backtracking problem, and then I think I understand how to use backtracking. So I'm gonna try to solve easy question that can be solved with backtracking. So this seems to be easy, and this might have some easier way of solving this problem, but this time I'm gonna try to solve this with backtracking. Okay, so let me set the timer to 30 minutes. Sorry. Sum of all subset XOR totals. The XOR total of an array is defined as the bitwise XOR of all its elements, okay, or 0 if the array is empty. Okay. Two, 5, 6, 1. Given an array nums, return the sum of all XOR total for every subset of sum. Subset with the same element should be counted multiple times. Subset with the same element should be counted multiple times. Does that mean that order is different but elements are same, right? An array A is a subset of an array B. If A can be obtained from B by deleting some element of B. Okay. Possibly 0. So 1, 3, the subset is 1, 3, 1, 3, and empty. 1, 3, 1, 3. So the answer will be 1, 3, 2. 1, 3, 1, 3. What is the answer for this question? Return the sum. Okay. 5, 1, 6. So 5, 1, 6, 5, 1. Then 5, 6. And then 1, 5. No 1, 5. What does this mean? Given an array, subset with the same element should be counted multiple times. Subset with the same element. What does that mean? Multiple times. And then I don't know why it. Oh, empty. Empty 0, 5, 6, 0, 5, 6. 2. Multiple elements subset with the same element. So one of my question is that is all the elements inside num unique? Num length 12, num 12, 20. And then it does not mention that thing. So let me turn 0. Let me try to run a case. Custom case plus what if I have 2 2? And then the answer will be input how can I 1 3? Oh, okay. Let's change this to 2 2. Submit, and you still this. Two, okay, 0 4. So 2 in case of 2 plus 2 plus 2 2, right? And in case of 1 bit 1 should be 0. So this should be 0. Then how about 2 2? 2 2 is gonna take a long time. 2 to 3. Run. Answer is 12. So 2 2 3, and then plus 2 2 2 3. So this is the first 2, and then first 3, and then second 2, second 3, right? And then everything. And then if I run this, oh, this is correct. Oh, so 3, so I cannot actually calculate, but it's the way how it is. Okay, so let me try to think about the test case. I spent already 7 minutes to figure out this problem. TC. So it should be more than 1. So let's say 1, and then we can have something like 2, and then interesting case 2 2 3. Yes. So then probably 2 3 4, right? So let's try to make case for this. And other interesting case, I guess if I do this correctly, then there can be 3 or 4 duplicate cases, but this algorithm must deal with this. Okay, so this needs so like 1 2 3. So if I select 1, I can do this with 2 3. If I select this, I have to do this with 3, right? And then like this. If I select 2, I have to do this with 3. this one and this one is same. And 3, 3. So first 1, 2, 3, and then 1, 2, 3. I mean this, and this one is same, and then so nothing, and then 3, 1, 3, nothing, because we already did 2. So this is 1, 2, and then 1, 3, and then 2, 3, right? 1, 2, 1, 2, 3. Correct. So the way we can do this is starting from this. Select this one, and then we have empty, and you can try the other. So empty, then we can try the other, right? So the way how backtracking works is like we have the way to operate something like this. This is 1, right? And then we have to roll back this operation. So what if we do like this? We will get this, right? And then this is 0, and this is 1, this is 0, right? So what I'm thinking is that if I do this and then do this, next round, the backtrack. Inside backtrack, let's calculate this from here. The size is 12. This is not a lot. So total, we have the partial total, and then some number, and then partial total. What if we do this again? So if the partial total is 1, and then if this was 1 and this is 1, the answer of this should be 0, and then the answer of this is 1. Okay, so we get this, and then 0, 0. Like let's say A. So this one, not A. Let's say 1. So 1 and then 1. We get this, and then this one is 1, and then again this one will be 1, right? And how about this? Should this be 0? And how about this? Should this be 1? So this one is 1, 1, 1, 1. Okay, so this is correct, and this one is 0, and then 0, 1 is 1. Okay, so this works. So the way we can retract is like that. So we have here we have a int partial sum, and initially it is num 0. So so here normally what backtracking does is that auto backtrack equals something which is into starting index, let's say the S starting index, which means that if the starting index is then we have into total sum, partial sum, partial total sum, partial sum. Okay. So what we have to do is for int k equals start, and then k is ampersand nums size k plus plus. So let's say that ps equals ps nums k, and then backtrack start so here you have to do this, right? And inside here, kind of confusion with the concept of k and start. So if k is 2, what we need to do is that we have to do this with this number, right? This should be k plus 1 and then ps. And let's roll back. Ps. Okay. And then backtrack. The weird thing with the lambda is that we cannot call this like this. They normally define this like a function. This time I'm gonna do this like this because I'm not quite sure about the syntax of function object. So void backtrack, and then we're gonna pass this like this. So nums backtrack, and we need some condition here, right? So one condition is that, okay, to, yeah, actually total sum, we need total sum, right? And then backtrack nums 0 ps total sum int total sum. And one thing I'm not sure is this initialization. This is one thing I'm not sure, because what's the rule? Okay, let's try to think about this too. No, 1, the initial case. So we call 1, and then inside backtrack, we have to do this, and then we have to do this, and then we have to do this. So here, total sum is total sum plus ps. So this means this one, and then this one and this one. Then in case of 3, it just add itself and then return. If start equals nums size -1, we should return. I'm not sure of this. So this guy, this is difficult. Actually, I'm not sure how to set up the initial state. That is one question, and then the second question is, backtracking is something like 0, 1, 2, 0, 1, 2, 0, 1, 2, and then let's backtrack to this. And then okay, good, to this 0, 1, 2. Let's backtrack. 2, okay. Which means that we have to go through all of this. So when I saw some of the explanation of backtracking, these are the way of how it works. But here, what I'm doing is that I'm doing some start. Which is different from this, right? I'm not gonna go this, I'm not gonna go this kind of approach. But, well, let's think again. So, this guy, I am the 1, right? And then let's go through from 2 and 3. Yeah. So this is how we handle 2 and 3. And then what it does is that, okay, 2. I'm gonna calculate your sum, partial sum. And then you handle yourself. So inside 1, 2, you first create this. Okay, I'm gonna add 1, 2 of the partial sum, and then it try to do from 3. Okay, 3. I'm gonna calculate PS for you, and then let's do this. So 1, 2, 3 is calculated in here, and oh, let's just return. I'm the end of recursion, so this is handled, right? This is handled. So now going back to the second one. Second one, so if this is true, then PS must be 0. Not sure whether this is correct. So at first, when PS is 0, this num can be 1, and then the PS should be 1. Oh, right. Oh, so this is correct. So this seems to be correct. And then, okay, so initially PS is 0 and TS is 0, so this is 0. So, and then blah blah blah, then this, I don't know why, backtracking. So starting from this one, so we'll start from this one, PS1, right? And then this goes this one inside, then it adds itself to TS. Okay, so second, this one, the next one, and then I did that before, and then third one goes in, and then K is now 2, and then third one, and then K plus 1 is a 0 is 0, 1, 2, now it's 2, so we'll return, right? So like this. So if we enter 1, then 0, 0. So this will be 0 initially, and then start is 0. So 0 we do once, and then it goes into here. So we add zeros, PS to TS, and then this is the end, so we'll return, right? So I think this is the one I was trying to solve. Let's try to run. But I have some error. Control H's. Total sum. Wrong answer. Output is 0. Output is 8. 2 to 3. 2 to 3. Okay. So initially it is 1 3. So okay, 1 3 4 6. Time is already finished. I guess I have 50 more seconds, but this is just study, so I'm gonna keep working on this. So 1 3, 1 done, 3, okay, and then 3 done, and 3 done. So this is basically the way I want. And then so let's start from 0 0 0. Everything is 0, so this is initially 0, and then we're gonna go through this from K. This is 1, right? Initially, I mean, this is 1, so starting another 30 minutes. Let's finish this within this time. This is 1, so 0 and 1 is 1, so PS is 1. So we're gonna, so PS is 1, and then we'll go into now start is 1, okay, so 1 plus 0 is 0, is 1. So now start is 1, so oh, okay, we're gonna finish and then return, and then this is 1 and 1, so PS will be 0 again, and then so previously start was 1, and then the size is 2, right? This is 1. Maybe this is wrong. The ending. So start 0, and then if start is 1, yeah, so this should be, yay, yay. Yay, it worked. Okay, so this is the answer for the backtracking. So there are a couple of things I need to remember through this experience. Okay, so I normally, sorry, I drank Coke. And a couple of things I have to remember is that the XOR, so A XOR, what was the caret? Where's the caret? So N, and then X will be A. So if I apply XOR 2 times, this is one thing I have to remember. Then what's the other thing I should remember? I don't know. What should I remember? Backtrack. I think backtracking has some pattern like this. So backtrack, and then some partial data, and then result. Do something on partial data, roll back, K for K, and then roll back partial data before K. Inside backtrack, if K seems okay, add partial data into result, apply. Yeah, yes, these are some of the rules. Oh, I may need to think about how I can solve this without using backtracking, because backtracking question is normally medium level, but this one is easy level, so there might be some other way to solve this, which is starting from this. Okay, 3, 2, 3, 2 and 2, 3, get a 1, 1, 1, 3, 1, 1. Can we generate all cases? So So from the back, 3 is 3, only one. And the next step, what you can do is only one and then this one. So so the TS is kind of sum of this one plus 2, 3 plus 2 then plus 1, 1, 3, 1, 2, 3, 1, 2, right? 1, 1, 2, 1, 3, 1, 2, 3, 2, 2, 3, 3. If we keep track of this thing, then we can solve this. So there are some solutions which people submitted. Editor is not available. Simple backtracking with the comment. Simple solution. C++ solution. Wow, this is not backtracking at all. Related is backtracking seems subset. This one is backtracking. Intuition find all subset, find the EXOR. How do we find the subset of an array? Let's say we have 1, 2, 3. You notice a parent here. The parent is first to include nothing to get empty array. Then you include the third element in 3. Second is 2. Then the first one. This was what I did. This inclusion and exclusion resembles the binary number ordering. Wow! While writing code to find subset recursively, what we'll do is follow the same logic. In the first call, we'll include an element, and in the second call, we'll exclude the element. Code, simple one. Solve. So here 0, 0. Array. Array file size, grand total, add this, include. Alright, I plus 1. Exclude. So basically this will have a 2 level of a tree, like for I0, I0 is 1, with and then I2, I3, for case, and then it tries to include this or not include this, and then grand total is reference, so 0, so in case of 0, 1, 3, what it does, so 0, 1, 3, 0. So initially this include, another case for the exclude, like include, exclude, include, exclude. Wow, this one is pretty neat. Wow. But the thing is, this one is a lot of well, in case of this one, my solution, I'm not gonna try if try this. But in this case, this guy's case, if to calculate 3, we have to make a recursion, like not exclude, exclude, and then include. So it needs more calls. But here's a fancy way of solving this. Yeah, this is good. I mean, for the brain training. And then recursion, easy. This is the one I saw. Simple backtracking. not sure. Brute force solution. Backtracking. Helper. 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 Why is this backtracking? This does not seem like a backtracking. I get we are using recursion over here, but can you please tell how we are using backtracking here? The same question. But we're still in the same, say, maybe the way, my way is better. But there are some guys who's doing a really good job. Backtracking, bit manipulation. Backtracking. No backtracking. So, include. Maybe I can submit this. Solution code. Okay. Remove this. Let's remove this. Partial. intuition. With a number a XORing n. If P and P A dash, then A dash XOR n is A. Backtracking is some kind of rollback. Here with the number A, so this is a RAID 3 RAID level. RAID 3, which is rarely used in practice, consists of byte level striping with a dedicated parity disk. Parity. So how to calculate parity? X. So general parity system. So wow. Should I read this? Anyway, RAID 3, maybe it's mirroring. Well, parity, so this is mirroring. RAID 1. What's the difference? Oh, this is mirroring. RAID 2, 3, 4. The AP, some calculation here. Release byte level striping of dedicated parity. One of the characteristics of RAID 3 is they generally cannot service multiple requests simultaneously. Blah blah blah. The reason why I am looking at this is that just forget it. Maybe not the same thing. So what we can do is int x equals 1, 2, 3, int y equals, let's say that some random number. Not a good case. See out x y and the line. This will be on to, oops. Yeah, this should be 1, 2, 3. Okay. Should I do this? And should I do this? It takes so long time. I'm not sure whether this is very general thing. Everybody knows 1, 0, and then this is 0. This is 1, right? And then this is doing n again. Zero, 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 right? And then 1, 0, which is 1, and then doing that again is 1, right? Likewise, doing this 1, this is 1, then 1, 1, 0, and then 1, 1, 0, 0, 1, 0, 1, 1, right? Let's not do this. It takes so long time. Okay, I respect other people who uploaded the solution, but I'm not that one. So okay, that's it. Bye.